Hello, Applied 30. We are into our last unit of the year, which is going to be quadratic expressions and equations. Honestly, I wanted to start with this if we were still in class right after statistics, but we're going to deal with what we've got. This is probably the most useful unit. We look at graphs, we look at curves. So you've seen linear relationships, linear systems, and inequalities, but working with curves is going to be a lot more useful to us. So for this video, I just want to show you the different characteristics of the curve, and we'll maybe take some notes on that so you have that information down, and then we'll look into some practice a little bit forwards. Okay, so I just dimmed the light so we can see this a little bit better. And this is what our curve ends up looking like. Now I'll show you what the equation is shortly, but just by looking at the line itself, there's some information that you can tell, which is going to be standard with every single one of these quadratics, or every single one of these curves. One thing is that there's always going to be a peak limit. So in this case, it looks like a valley that goes and it drops up until +2. Sometimes you'll see something like a mountain where it goes up and the peak of the mountain is at a certain point. That is called our vertex. I'll explain what that looks like shortly. We also notice that our curves are always perfectly symmetrical. So this one intentionally is symmetrical of the y-axis. So you can see the y-axis going up and down. It's splitting our curve perfectly in half. And it just looks like that in this picture. Sometimes you won't see all of the curve, but it still always splits perfectly in half. That line that splits it perfectly in half is what we call the axis of symmetry. So it's an axis. Sometimes it's your y-axis. Sometimes it's an equation of a line that gives you a straight up and down line. In this case, it's both the y-axis and an equation that gives you a straight up and down line. Do you remember what the equation of the straight up and down line that covers the y-axis is? It's x equals 0. When x equals 0, any y value is fair game going up and down. The last thing that you might want to take note of is that the domain and range of this type of shape. So the domain is going in the x directions, left and right. And for these curves, unless you're otherwise defined, it's going to be an infinitely long graph. So you can see how the line is going to the left in this direction, and it's cut off by the limit of our screen. But if we had an infinitely large graph, that line would go on forever to infinity in the x direction. Pardon me, it would go on to negative infinity in the x direction. Infinity would be in the opposite side, but since we're dealing with a symmetrical graph, if one side is going to negative infinity, the other side must be going to positive infinity, unless, of course, there is some other limitation or inequality at play, but we'll deal with those when we see those. The range is where it's going to get a little bit more tricky, because there is always going to be a limit to your range. You're never going to have negative infinity to positive infinity in that sense. If you have a graph that is a valley, you are going to have a minimum, so in this case it's +2. The maximum is infinity. If you have a hill, which goes in the opposite direction, you're going to have a peak, which is the upper limit of your range, but your lower limit of your range will be negative infinity. So negative infinity to wherever that point might be.